Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? So here we have to solve this problem in which the integral from half to 2 dx over 2x plus 3 times of fractional part of x is equal to log of 7 raised to 1 over alpha. Then we have to find the value of alpha, right? So viewers, this is a very elementary problem in definite integrals involving fractional part function, right? So what we will do, we'll first take this integral as I, right? So I is equal to integral half to 2 and dx over 2x plus 3 times the fractional part of x, right? So we'll try to find the value of this integral, and then we'll equate that value with this value, and we'll compare both the values, and then we can find out the value of alpha, right? So here the fractional part function is involved, and we know that the fractional part of x is defined as x minus greatest integer of x, right? So this is the definition of fractional part function, and we know that the domain of the fractional part function is the set of all real numbers, and the range is from 0 to 1, right? So the range is from 0 to 1. So now what we will do, we'll take this fractional part of x is equal to x minus greatest integer of x over here, right? So now we have the integral half to 2, then we have dx over 2x plus 3 times x minus greatest integer of x, right? So now we can solve it. So we have half and we have 2 here, dx over 2x plus 3x minus 3 times of greatest integer of x, and here we have half to 2 dx, and we have 5x, 2x plus 3x is 5x minus 3 times the greatest integer of x, right? So now we have to solve this integral, right? And here we see that x varies from half to x is equal to 2, right? So now if we take these points on the number line, then here we have 0, here we have 1, and here we have 2, right? And half, it lies somewhere here. Here we have x is equal to half and 2 is here. So now we see that between half and 2 we have this integer 1, right? So what we will do, we'll break this integral as a sum of two integrals, that is I1 and I2. So now I1 is from half to 1, right? From half to 1. So half to 1 we have dx over 5x minus 3 times greatest integer of x plus I2 is from 1 to 2, right? So here we have 1, here we have 2, and we have dx over 5x minus 3 times the greatest integer of x, right? So now I is equal to the sum of these two integrals, right? And 1 is the point, that is the integer where we have split this integral I as a sum of two integrals. Now let us first consider this integral I1, right? So here we see that x lies between half and 1, right? So x lies between half and 1, and here x lies between 1 and 2, right? So from the definition of greatest integer function, we know that whenever x lies between half and 1, then the value of greatest integer of x is equal to 0, right? And when x lies between 1 and 2, then the value of the greatest integer of x is equal to 1, right? We can also verify these results by taking particular values of x, right? So now in the next step, for this greatest integer of x, we can write 0, because x lies between half and 1, and in this integral, for this greatest integer of x, we can take this value 1, right? Because x lies between 1 and 2. So now I is equal to, we have half to 1, and we have dx, and we have 5x minus 3 times 0, then we have 1 to 2 dx over 5x minus 3 times 1, right? So now this integral is half to 1 dx, and this is simply 5x, and here we have 1 to 2 and dx over 5x minus 3, right? So now we have two simple integrals. So now the value of the first integral is 1 over 5. We can take 1 over 5 outside, and we have the integral of 1 over x dx, right? And that is equal to log of x, and we have the limits half to 1, right? Because we know that the integral of 1 over x is a log of x, right? And in the second integral, see here we have 5 as the coefficient of x, so we have 1 over 5, and the integral of 1 over 5x minus 3 is 1 over 5 and log of 5x minus 3, right? And the limits are from 1 to 2. Now here we have used the result, that is dx over ax plus b is the integral of 1 over ax plus b is 1 over a log of ax plus b, right? So either we can take here positive sign or negative sign. So we can take here plus minus, so here we'll have plus minus. So now we can simply substitute the limits here. So we have 1 over 5, this is log of 1 minus log of half, right? And here we have 1 over 5, and we have log of, see here we have x is equal to 2, so this is 5 to the 10, 10 minus 3, 7, minus here we have x is equal to 1, so 5 ones are 5, 5 minus 3 is 2, so we have log of 2, right? And here we have 1 over 5, and log of 1 is 0, and here we can take log of 2 raised to minus 1. Here we have 1 over 5, and this is log 7 over 2, right? Because here we have used the result log m minus log n is equal to log of m over n, right? And now here log of 2 raised to minus 1 is minus log 2, right? Because log of m raised to n is n log m, right? So now we have 1 over 5, and this minus when multiplied with this negative sign we have plus, so we have 1 over 5 log 2, and here we have 1 over 5 log of 7 over 2, right? So now we can take 1 over 5 common, so we have 1 over 5, and we have log of 2 plus log of 7 over 2, right? And this is 1 over 5, and this is log 2 times 7 over 2, right? Because we know that log of m plus log of n is equal to log of m multiplied n, right? So here 2 and 2 get cancelled, so we are left with 1 over 5 and log of 7, right? So viewers, the value of this integral, that is I, is equal to 1 over 5 log of 7, right? So now this expression, that is 1 over 5 log 7, can also be written as log of 7 raised to 1 over 5, right? That is the fifth root of 7, right? Because here we have used this property, that is log of m raised to n is equal to n log m, right? And now we are given that the value of this integral is log of 7 raised to 1 over alpha. Now if we compare both these results, we see that 1 over 5 is equal to 1 over alpha and alpha is equal to 5, right? So the value of alpha is equal to 5. So this is how we solve this important and conceptual integral.